Alright guys, today we're going to be looking at lesson 5.3, identifying proportional relationships. So when we're looking at a proportion, we can see that a proportion is an equation stating that the values of two ratios are equivalent. So a proportion has a ratio on either side and an equal sign in the middle. So here you can see the example they gave is 2/3 is equivalent to 4/6. So if we try one, the first example here says that 4/10 is equal to 6/12. So the easiest way to figure out if these form a proportion is to simplify the two fractions and see if they are in fact equivalent. So if I do that, I could see that 4/10 would simplify to 2/5. And 6/12 would simplify to 1/2. So these are not equivalent. This is not proportional because those two values are not equal. Okay, on the other hand, if I compare 8/20 to, on the other side, we have 4/3 over 10/3. So if I simplify here, 4/3 divided by 10/3, I'm going to do that on the side. So 4/3 divided by 10/3, I'm going to do keep, change, flip. Those 3's can cancel. 4 can become a 2. A 10 can become a 5. That would simplify to 2/5. Here I could divide by 4 and divide by 4, which would also be 2/5. So these are, in fact, proportional. Another way that you can determine whether something is proportional is to look at the cross products. So if you look here, the cross products means you would be multiplying on the diagonal. So you would multiply A times D and B times C. And if those values are equivalent, then it is proportional. And if they're not equivalent, then it would not be proportional. So let's try that on these examples here. So we have 2/3 to 12/18. So if I multiply on the diagonal, 3 times 12 is 36, and 2 times 18 is also 36. So this would be proportional. Okay, if I try the one next to it, I have 2/3 equal to 4/5. So here if I multiply, 3 times 4 is 12, 2 times 5 is 10, so this is not proportional. Alright, you can use either method here. You can use the simplifying method that we used in example 1, or you can use the cross product method that we did in example 3 here to determine whether the following questions are proportional. So go ahead, pause the video here, try these problems, and then when you're ready, you can resume the video and check your answers. All right, I'm going to go ahead and start here. So I have 12 to 6 equal to 8/4. This one I'm just going to simplify. These both simplify to 2, so this one is proportional. The next one I have 14/8 equal to 28/10. So here if I multiply 14 times 10 is 140, and 8 times 28 is 224, so this is not proportional. The next one I have 8/28 compared to 4/16. If I simplify here, if I divide this by 2, I get 4/14. which I can see is not equal to 4 over 16, so this is not proportional. The next one I have 6 over 36 equal to 4 over 16. This is 1/6. I'm going to switch colors. If I simplify, I get 1/6 to 1/4, and those are not proportional. The next one I have 6 over 24 compared to 8 over 32. So if I simplify here, I get 1/4 equal to 1/4. So this one is proportional. Number 6, I get 3/4 compared to 6/8, which 6/8 would simplify to 3/4. So this one is proportional. Number 7, I get half over 3 compared to 1 over 6. This one, I can multiply this one by 2 to see that that would also be 1/6. So that is proportional. Number 8, 8 over 3 equals 18 over 6. This one is not proportional because if I divided by 2, I would get 9 over 3, right? And that is not equal, so that is not proportional. Number 9, 7 over 12 equals 14 over 28. This one is not proportional because if I multiplied by 2, I get 14 over 24, which does not equal 14 over 28. Number 10, I get 8 over 12 equal to 2 over 3. I'm going to multiply here because these numbers are pretty easy. So 8 times 3 is 24, and 12 times 2 is 24. So this is proportional. The next one, I get 4 over 30 compared to 8 over 1. So here I can see right away that if I multiplied, 4 does not equal 240, so that is not proportional. And then the last one over here, I get 3.5 over 10 compared to 10.5 over 30. I'm going to cross multiply here. So 3.5 times 30 is 105. And then 10.5 times 10 is also 105. So this one is proportional. All right, looking at the next example, it's telling us to decide whether these tables are proportional. So if I'm looking to decide whether a table is proportional, I want to look at what they're multiplying by. I also drew a graph here, but I don't think I need to do it with a graph. So I'm going to actually delete those because we haven't done graphing yet. I'm going to get rid of those. Okay, so if I'm trying to decide whether these tables are proportional, I'm going to look at what we're multiplying by in my x and my y to decide if we're going up by the same amount. Or to decide whether something is proportional, we can look at our y over x. Okay, so we use the letter K for the constant of proportionality, which we'll look at coming up. But I can look at that y over x value. So if I look at y over x, I get 4 over 2 is equal to 2 over 4. Right away I can see that this one is not proportional. For the next one, I get 2 over 1, 4 over 2, 6 over 3, 8 over 4. This one I can see that they're all proportional. Okay, I can see that we were multiplying by the same amount. If I look inside my table, right, we did times 2. That was the same thing that happened down here. I'm going to move this over. That was times 2, right? The next one was times 3, and then times 4, and times 4. So we kept multiplying by the same amount to get those values. Or you could see when you simplified your y over x, you always ended up with a value of 2. So this one is proportional. And then that last one, same idea. If I looked at my y over x, or going from piece to piece, right? 1/2 to get from 1, I do times 2, which matches on the other side. To get from 1/2 to 3/2, I do times 3, which matches on the other side. And from 1/2 to 2, I have to do times 4, which also matches on the other side. Okay, again, I can also decide that by doing y over x. So 3 over 1/2, or 6 over 1, 9 over 3/2, or 12 over 2, right? Each of these simplify to 6. So this one is proportional. Okay, so we want to basically look at, if I was completing a ratio table, are these the values that I would find inside the ratio table? Does this work? All right, and then this word problem here, it says you swim 16 minutes and complete 20 laps. So I'm going to make a little table with this information. So I'm going to say minutes and laps. So this one says that I do, in 16 minutes, I do 20 laps. Okay. Over here, the information that I received was that, again, minutes and laps, it said my first 4 laps were done in 2.4 minutes. How long does it take you to swim 10 laps? Can you determine that with certainty? So let's look at each of these to do 10 laps. So in the table in red, if I did 10 laps, that would take me 8 minutes, right? I got that by just dividing by 2. All right, in the table in blue, I'm going to see, well, if I divide by 4, 1 lap would take me 0.6 minutes. So then I'm going to do times 10 and see that 10 laps is going to take me 6 minutes. So I can see that this is going to take me somewhere between 6 and 8 minutes. But I can't determine this with certainty because I can see in the beginning I was swimming faster, and then as I was swimming, I slowed down. Okay, so right as I went for a longer time, my pace started to slow down. So this was not proportional, so I cannot determine this with certainty. But somewhere between 6 and 8 minutes, again, it was not proportional, because it wasn't going by the same thing every time. All right, and then our last question here says which ratios does not belong with the other 3. So again, I'm going to solve that by simplifying. So if I simplify 4/10 by dividing by 2 and dividing by 2, that ends up being 2/5. 2/5 is already simplified. 3/5. And then here I can divide by 3 and divide by 3. So I also get 2/5. So the one that doesn't belong is 3/5. The other one's all simplified to be the same. All right, that is the end of our notes section. So you can put away your notes packet and return to the agenda to see what we have to do next.